Use the method of differences to show that this summation can be written as this, like it. So the first thing I'm going to do is forget about the summation. Let's rewrite this using partial fractions. 2 over r plus 4 times r plus 6. Then this will equal a over r plus 4 plus b over r plus 6. Multiply through by r plus 4, r plus 6. We're going to get 2 is identical to a, r plus 6 plus b, r plus 4. Let r equal minus 6, then 2 will equal minus 2b, b is going to be minus 1. Let r equal minus 4, then 2 will equal 2a, a will equal 1. So our summation is then going to equal the sum from r equals 1 to n of 1 over r plus 4 minus 1 over r plus 6. Brilliant. Now we can start subbing in terms, and we're going to use this method of differences. Lots of them are going to actually cancel out. So let's sub in 1. We're going to get a fifth minus a seventh. Then I'll sub in 2. I'm going to get a sixth minus an eighth. Like, nothing cancels so far because the difference between 4 and 6 is 2. But if we put in another term, when r is 3, we're going to get plus 1 over 7 minus 1 over 9. And then we see that these two will cancel. Let's put in one more. When it's 4, I'm going to get plus 1 over 8 minus 1 over 10. So now I see those cancelling. And it's just, now we've kind of gone beyond the 5th and the 6th. Those are going to stay. But then these are going to cancel with like other ones later on. It's just you're left with 2 that don't cancel. Let's take a look at the very last terms. So we're going to get as our last one minus 1 over n plus 6 and a 1 over n plus 4. Now that we kept the first and the third, and then the fourth one cancelled with 1 later on, but that means there's not going to be 1 to cancel with this one here. That one's going to stay. The 1 over n plus 4, however, is going to end up cancelling out. But let's write a few more down just to illustrate that. So now I'm going to be substituting in n minus 1. I'm going to get minus 1 over n plus 5 and plus 1 over n plus 3. So none of these cancel. By the way, I'm also expecting to keep this one. And you can also see I've got 2 positive ones. I'm going to have to be left with 2 negative ones. But if I go with n minus 2, then I'm going to get, sorry, I should have had a plus there. Then I'm going to get minus 1 over n plus 4. And then here, I'm going to have 1 over n minus 2. And now I can see that those cancel. If I go with n minus 3, I'm going to get 1 over n plus 1 minus 1 over n minus 3. And then I see them cancelling. And the same kind of way I can say, right, these are going to cancel with ones before it, and I'm going to be left with these. So the summation. Now let me actually add the 5th and the 6th together. It's going to be 6 over 30 plus 5 over 30, 11 over 30. Then minus 1 over n plus 5 minus 1 over n plus 6. Oh, that is actually, yeah, summation in terms of n. We've just got to now rewrite it as this. You can see the 30s in there. So this is all looking great because we're going to be putting over a common denominator, and you can see we've got the correct common denominator. All right, let me multiply this one, the first one, top and bottom by n plus 5, n plus 6. Get this. For the second one, I'm going to times by 30 n plus 6, because that will get me the same denominator. I'm not going to write it all out again. And then for the last one, I'll times by 30 n plus 5. Again, all over the same denominator. This will give me 11. Right, I'm going to start multiplying it out. 11 n squared plus 11n plus 30. Then minus, I won't expand this out quite yet, minus 30n plus 6 minus 30n plus 5. gives 11n squared plus 121n plus 330 minus 30n minus 180 minus 30n minus 150. Now minus 180 minus 150 is 330, so these just cancel. And 121n minus 60n gives us 61n. And finally, just going to factorize out the n. I will get 11n plus 61 over 30, n plus 5, n plus 6. Nice question. Well done.